Ladies and gentlemen, boys and girls, children of all ages, welcome to my favorite lesson. Not because of the math itself, but because I get to say OofO over and over and over and over. I hope that you're watching this at home and going, OofO? I hope you say it out loud because it's fun to say. Try it now. OofO. Like, no, really. You should say OofO. I've got Mr. Gill in here. Mr. Gill, the camera's at you now. Can you say OofO once?
OofO. It's guile.
Oh, man, it's guile. Oh, my gosh.
Is the OofO that thing that you use in the shower to write?
Close. OofO is not loofah.
Oh, right.
I love OofO. You have done this multiple times. Now my camera's all turned sideways, y'all. Okay. OofO is the order of operations. When Mr. Guile and I were in math class, we learned it as PEMDAS. Please excuse my dear Aunt Sally. And when I became a math teacher, I wanted to have like a really stern talking to whoever did that, because it's not correct. PEMDAS, which is parentheses, exponents, multiply, divide, add, and subtract, is wrong. You need to understand the order of operations as GEMDAS, because we are all smart. The G stands for grouping symbols. And that is important. Grouping symbols can include, but are not limited to, parentheses, brackets, absolute values. Those are all grouping symbols. Now I'm going to add one, which as you get higher in math, Algebra 2 will be learning it this way, that aren't really grouping symbols, they're exponents, but we're going to assume for our math intent purposes that they are grouping symbols. The square root symbol needs to have everything done inside of it first, and the cube root symbol needs to have everything inside of it done first. Those are some, but not all, of the grouping symbols. Then the E, which is our second step, are exponents. Exponents are something with our base and the power, 3 to the third, 5 to the 7th, 8 to the negative second. And remember, we can't have negative exponents, so that would really be 1 over 8 to the second, but I'm getting ahead of ourselves. Then we get to the tricky ones, M and D. And you're like, Mr. H, this isn't tricky. I know it's multiply and divide. Yes, you do. But every year that I have taught this, multiply and divide has been tricky because students want to do all of the multiplication first and then all of the division. Because Mr. H, look, it goes multiply then divide. Wrong. When we get to this step, we are working our problem just like we read a book, left to right. If multiplication comes first on our left-hand side, then we do multiplication first. If division comes first and then it's followed by multiplication, we do division first. We work from left to right once we get to this step. The same thing happens down here when we get to the A and the S. So addition and subtraction. One more time, this is where I will see a lot of mistakes. Some of the easiest things that are causing problems are with these two because we're not working them from left to right. So you want to have this down with GEMDAS, grouping symbols, exponents, multiply, divide, add, subtract. So what we are going to do is we are simplifying. That means take a big problem and work it down as small as we can get it. So we are going to simplify something like this. So here's our first example. 3 squared minus 2 plus 4 times 3 minus the square root of 100. Okay. The way that I like to explain solving order of operation problems is they are going to have a tornado effect. We start big and we're coming down and making a funnel cloud. Okay? The man who grew up in Pittsburgh, Pennsylvania, who knew nothing about tornadoes, trust me, since I've been out in Kansas City, I know what a tornado looks like now. Okay? So y'all, we're gonna bring it on down. Okay? First step, is there grouping symbols? Yes. So I start from the left to right. Here's my grouping symbol. Inside of the grouping symbol, I have 2 plus 4 times 3. We still follow the order of operations inside the grouping symbol. So there's no exponents, but there is multiply and divide. So that goes first. So I do 4 multiplied by 3 is 12. And I rewrite my problem. This is a step that I want to see. I want to see you rewriting the entire problem so that I can see where you make mistakes. Hey, you know what? God made me a sinner. I make mistakes every day. Making mistakes is all right. It's part of the struggle that we're going to do when we do tough things. So if you make a mistake, that's what I'm here for, is to help you fix it and to help you learn. So even though I said, when you make a mistake, guess what? We'll all make a mistake this year. So here I am, I still have my grouping symbol. So now I have my 2 plus 12. So I rewrite 3 squared minus by 14 minus the square root of 100. I've now done everything inside of my grouping symbol. Remember, I said, hey, the square root's a grouping symbol. In Algebra 2, it's not, it's an exponent. But again, I digress. So now I have to do the square root of 100. So now I have 3 squared minus 14 minus the square root of 100 is 10. Notice what's happening. Here's my funnel cloud. There's my tornado. So now I'm doing my exponents. 3 squared is 9. Minus 14 minus 10. Okay. Well, multiply, divide. There's nothing to do there. Add. No add. There is subtraction. So I do each part individually. 9 minus 14 is negative 5 minus 10. So remember, these are different terms with different signs. When we have different signs, we forget about the sign. We subtract the numbers. We place the larger sign from the absolute value back with it, which is how I get a negative 5. Same signs, negative 5 minus 10, negative, negative, gives me a negative 15. And I have simplified all the way down. In your book, you will hear the word evaluate. We are evaluating this expression. An expression is a mathematical statement that has no equal sign, but has mathematical operations. So this is an expression. The difference between expression and equation is that equal sign. There is no equal sign. We simplify and we evaluate expressions. We do not solve. I'm big into math. If you can speak the language of mathematics, you can do mathematics. Everything falls in line with the order of operations. Obviously, that's just one example. If you have questions, we're going to do a bunch of these in class together. As always, I love you, kiddos. Let me know if you have any problems.